Okay, so yes, basically it's the backbone of any business is their data. It's used in every single department, marketing, sales, engineering, literally every business needs to have an understanding of their data, which is why SQL is just incredibly important. So we can ignore the my Postgres part because we're using MySQL if you have downloaded it, but it's okay, technical difficulties. So I'm just going to begin with kind of the first step to any. I'm not even going to start teaching you SQL right now. I literally just want you to look at the data. So we're just going to go to the file that we have. You can download it. It's in the doc. It's just on GitHub, so that'll work for you. So basically we have this. If it loads. Sorry, nothing's working. Okay, so basically we have this whole entire file. It's called employees.sql. And this is just kind of what it looks like. But basically, sorry, I like in VS Code better, so I'm going to show you here. Basically, we're just going to look at like the structure of it. So we can see here that we have a table. It's called employees. We have another table. It's called departments. We have another one, department manager, another one, department employee, titles, salaries. Okay, so we're basically just getting an idea of what is in the data. This is what we're looking at. I like to think of this as kind of like your Excel sheet. So basically you have your whole entire Excel, which is what we're calling employees. And then each like sheet is like a table. And basically this, what we're learning is like a relational database, which just means that everything's organized in rows and columns. So yeah, kind of getting familiar. Okay, this is the table structure. And then if you go back to GitHub, you can see that like, okay, if you go to like load employees, we're going to view this raw because there's a lot of data, so it doesn't load. But well, you can see here that we have the first name, last name, their gender. So this is all the information that is in the tables, basically. These are rows and columns of like the Excel sheet. Yes, so, okay. So that's just like kind of basic data structure. If you have any questions at any point, just like let me know. But now I'll like start with the SQL portion. So I'm just going to use SQL Workbench or MySQL Workbench because I don't know, it's easier, it's prettier. So if you had downloaded it, basically the first commands you do is just kind of like use employees, which is what we're using. I already did that. And then if you want to like see the tables, you just click show tables. And to run it, you just click Command Enter. And here we can see that we have all the tables. See the current department, departments, department employee. Basically, this is just what we have. You can also go over here into the schemas tab and see all the tables, the views, everything. Everything's under here. So that's how you kind of use it at first. And then just simple query is just select all from salaries. So if you just like run this, you can see that this is everything in the salary table. So that's just like kind of how you run. That's like the most basic queries, just select all from whatever table. Yes. So basically, I'm just going to explain how to create a table. Feel free to like take notes on this part. So basically, the first thing you want to do is literally just type create table. And so I'm just going to do this really quickly, like in the workbench. So you can type create table, and then we're going to name the table. So for my example, I'm just going to do person. I'm just going to run this really quick because I already created it when I was practicing. Okay, so we're just going to create table person, and then you open the parentheses, and then you're going to click enter, and then you want to add all basically the rows to the table. So for example, we're just going to use like social security number, and then so right after this, what you have to do is say what kind of variable it is. So there's integer, there's characters, which is like varchar, and then there's like date. So there's basically the three options you have. There might be more. Those are like the three main ones you use, just integer, character, and then date. So honestly, I just don't feel like typing this out. Like, so I'm just gonna copy and paste it, but I'll explain everything. So this is basically like how you create a table. So we can see here that we have the integer because social security number is a number. And then right here with not nulls, we have not null means that this field cannot be empty. So when you're entering in the data, you'll get an error if that one field is like not there. So if I was like putting in a piece of like a row of data for this and I did not include the social security number, it wouldn't work. Like you wouldn't be able to enter in that row. And then after this, you have to identify in each table a primary key. And the primary key has to be unique. That's like the main thing. It has to be a unique identifier. So like social security number, like every one of us has a different social security number. So that's like a unique value. And then for like, I don't know, like our Cal Poly, like, what are they called? Cal Poly. Yeah, okay, Cal Poly IDs. Like we each have a different one because that's how they uniquely identify us like at the school. This is like how you know that each row is like everything, because I can have the same first and last name as like someone else. Yeah, that's very important for like joining tables later. So that's why I'm emphasizing it. And then for the varchar, that's just, okay, it's a character. It's like my name is, it's letters. And then you want to say how many letters it can be up to, which is where the 50 comes from, or no one's name is 50 letters, but like you just give kind of an idea for like how big the data field is going to be. And then like gender is the same. And then date is just saying that it's going to be a date. And basically it'll put it in like a date format for you. Yeah, so basically that's all the rows in my table. And so then at the end of each query, you have to end it with, you have to close parenthesis to like end the table. And then you have to end everything with a semicolon. It's kind of annoying, but that's how you know it's the end. And then if we click Command Enter, we can see here that it created the table person. So it was like successful. Any questions so far?
Yeah, with the primary key, if like say the data did have two the same social securities, would that like result in an error?
Yeah, because you can't add, you wouldn't be able to add another piece of data if they had the same social security numbers, because it has to be unique. So the second piece you're trying to add, like it wouldn't be added because it'd be like, okay, error, like it's already in the table basically.
Okay.
Yeah. Okay, this. Okay, so basically in order to like see that the table kind of worked, you just say describe person and they'll tell you all the rows. So it tells you the fields. So we have first social security number, first name, last name, gender, date of birth, country of birth, and it also tells you the types of what the data is, and it tells you if it has to be null or not. This is such a quick way to see like what the data is again. It kind of works like data exploration. Okay, now to like kind of starting actual queries. So first thing we're gonna do is just like select, we're just say select all from, I'll check it out. Select all from titles. So basically what the star means is you're selecting everything. It's not multiplication in this case. And then the from titles, we're taking everything from the titles table. So when I run this, this is probably like a lot of data, but we see we have everything from this, from the table. So we have like employee number, the title, from date to date, like when they started and ended. And in this case, when I was looking at this date doesn't make sense, but I think that's just means that like they're still employed. So they just put a random number as opposed to like when they ended, like this one.
So this is the table output?
Yeah, this is like the table output. This is like basically, yeah, this is everything in that one table. And if we wanted to, we could also, I'm gonna show you this next, but we could select like certain just rows if we wanted to, so that it doesn't show everything else. But like another thing we do is literally just say like select titles from titles. Yeah. So select title from titles. And then you see we only get the titles. Another cool thing we can do is I'm just going to show you a different table really quick. So we have another table called departments, right? And so I want to see all the department names. Let's just do that. Department name from. What oh, well, wow, I can't. You're right. So yeah, the wonderful thing about editors is that you just go back and do it again. Okay, so we can see here that we have all the department names. Yeah, and then another cool thing, a cool keyword you can use is like distinct. It doesn't really work in this case, but I'll just kind of show you. Basically distinct. Oh my voice. Basically distinct is, okay, I'll show you with this. Distinct, I can't spell. Title from titles. So you know how earlier we had every list, every title repeated because like that was we also had those associated with like the name basically. When we run this, see that it only shows like those distinct titles where it's different. So yeah, so instead of repeating like staff 50 times because it was like in it, if you just want to see like, okay, there's like this many staff, like whatever, or not that many staff, like I'm explaining this poorly, but do you get it?
Yeah, one thing I was talking about was like, if you said a data, obviously you can't go through every line and see there's repeats, but there might be like a couple of repeats in the data. Safe that just like the same like this. If you don't want to yeah. I mean, I
Like
guess.
say it again.
Just like a lot of times, like let's say you have a huge data set, but you like with 1,000 customers.
Yeah.
There might be like 2 repeats, but you don't know. Would it be safe bet just to put distinctly regardless of if it has or not? Because if you put distinctly, there's like no duplicates.
Yeah.
So
It's safer, yeah. That's why that's a lot.
I mean,
That's
I
one
guess we
reason
could
people do
compare
it.
the amount of rows that are output between the distinct, obviously. There's less rows for the.
But then it's like you have to search through it and like
Yeah, it kind of sucks.
Yeah.
that's when you combine Python with it and then it like magically works. So basically you usually use like SQL and stuff in combination with like other languages. Just fun fact. Yeah, so that's like distinct for you. And then I'm just gonna show you aggregates really quick. Do you have any coding experience?
Yeah, are a little bit of Python.
Okay, cool. So kind of pretty basic. We have all the same things as every language. You can add, subtract, you can divide, multiply. You can do power. Yeah, so you just want to like do simple math equations really quickly, like what 10 plus 90. Whoa. And then you get this beautiful little table and boom, it's 100. Okay. And you select like 10 times 10. That's also 100. Yeah, so pretty basic math, just you can also use it in SQL. It's helpful when, okay, this is like a helpful little thing that I just like to teach people. When you say like select now, it shows you the time and date right now. And that's often helpful just in like bigger queries or when you're trying to find like dates of things or like, okay, when did this person like, I don't know, all the customers that purchased within like now and like yesterday or something like that. So just a helpful little, I don't know what it's called, line of code. Yeah, so you can also like say interval. So if you want to like say like now like +1. So if you want to see like the future or like you can subtract it too. Yeah. So another thing you can do is just take the sum. So you say like select sum of actually the salaries from it's salary, table salary, right? Salaries. From salaries. And that's a big number. That's how much like all the salaries of everyone is basically. And you can also do like the average of the salaries. So this should be a smaller number. Yeah. So this is the average. That means some people are not making that much. Okay.
This is like back in the 90s.
Yeah, it is the dates. Yeah, that's true. Yeah, so that is how you select. And then, oh yes, count. Count is important. You'll be using count a lot. So basically this is when you're counting. Okay, so like salary and like average sum, whatever, that's used for like quantitative variables. Count is used for like qualitative ones. We like want to count how many like people are like in this or like are in the marketing department and you want to say, okay, that are in marketing. So like select count. Where should we, yeah, we'll do titles. Titles. This is like just how many. Sorry. Yeah, so this is just how many like titles there are total. This is not doing distinct. So, yeah, this is. It doesn't seem right, but
It's like count.
it was.
You know, but
You can put distinct inside count.
Yes, thank you. I was like, that is too big of a number. Yeah, one thing that happens a lot, honestly, when you're like querying, you're like, that seems like a very far off number. And yeah, so always make sure it makes sense. Yeah, so if it doesn't make sense, then you're like, yeah, you need to clean the data. It's just incorrect data. You're using the wrong numbers or wrong fields. Lots of things could go wrong. Data is very complicated, but yes. Yeah, so, and then, so basically now I'm gonna teach you like filtering, which is also like the where clause. Yeah, so I'll just show you an example. So we just wanna like select all from departments where, normally you do it on like another line, where department equals marketing. This is case sensitive, just so you know. Oh, it's department name. Sorry, I don't know that. Okay, and then you can see that it does.
the departments just have to list all the departments.
Oh, you're correct. I was expecting like take it from employees or something, but then you had to join the tables. We will learn how to join tables too. Okay, so that's just how you do it for like one row. But then if you want to filter by like multiple things, there are keywords that are like and, or, between, or like. So I'll show you just, we'll do or first. So we can just like copy and paste this and then say where department name equals marketing, or department name equals sales, engineering, sales. Okay. It works. Yeah, you can use single or double quotes. It is case sensitive.
I thought it was case insensitive. Oh, actually, no, case insensitive when you use like.
Okay. Yeah, so this is.
Most of the time you will end up using like, I will say that, but I'll show you that in like 2 seconds.
Yeah.
Yeah, because, sorry.
When you want it sensitive, I think you do like binary.
Yeah,
When you want sensitive.
if you want a case sensitive, you have to use like binary and then.
You want to try that?
Sorry, where,
Maybe just replace the equal sign with like.
oh yeah, I was gonna show that next.
Well, it's just
Yeah, it should be exactly the same.
Like,
binary.
okay,
It's the same.
Like, yeah. Let's see, see now it's binary.
Like binary is the same.
Yeah.
Like is essentially the same, but it doesn't look at case.
yeah, so like is,
Go like for sales.
no, wait, I thought like to,
Wait, I just go like, yeah, I think it'll show that.
Like is case sensitive.
okay. The reason why I use like is because it's very rare that things are exactly equal, or especially if you're, a lot of times, like in business, you'll get information from customers that they'll like fill out, and there'll be like a typo, or like they'll lowercase like their job title or something from like a form. So most of the time you just use like, but if you want to exact, then clearly use equal. Yeah, so that's, yeah. Also instead of or, we can use and this will be like the same thing. Okay, so since no department name is marketing and sales, you get absolutely no data back. Yeah. Okay, yes, with like, another thing you can do is, I'm just gonna delete this. Is if you want, well, I'm gonna change this to employees because we'll have more data to look at. Like, so basically with like, you can say like, if I want their name to start with an A, then I just put the little module after modulus. And I get all the people's employees' names that start with an A. So if you see here, they all start with just an A. If I want it to end with an A, I just put the modulus after. And then I get all the names that end with an A. And then if I want it just to contain an A, I can put the modulus before and after. And then a lot of names have A's. So you see how all these names have A's though. So yeah. Questions, comments?
So that last one you just did, it can also, it'll also look for like the first letter and last as well.
Yeah. Yeah, it's just if it's contained in the name. Okay, so there's also another operator called in, where basically if you just wanted to, okay, so basically if you just want the department name to be, okay, there's no engineering department, as I come to realize, but if you just want it to be in one of those three, so this is like more of a list kind of thing, where if it's in this like list of names, then yeah, so sometimes that's just quicker. If, I don't know, if you have like more than 3 items, I'd say it's faster. Otherwise, like this way is like solid. So yes, that's in, and then okay. Awesome, we have 8 minutes to explain joining. So very important thing in SQL is learning how to join tables. There's a cute Venn diagram I have somewhere that explains it better. But basically, if we want information from like multiple tables, but like we basically need to join them together in order to get the information from both tables. So there's multiple kinds of joins. Is there a whiteboard? Oh, okay, so we have left joins, right joins, full outer joins, inner joins, and yeah, so basically left joins is when you take a table and then you want another table and you say left join on it. It basically takes everything from the initial table and then all of the records that are on both tables, it'll add based on the primary, on the foreign key. So the reason why we had a primary key was so that we could join tables, because there has to be a foreign key on the other table in order to join it that is like the same thing. Does that make sense?
Yeah.
I'm going to show you. I'll demonstrate. If someone can explain it better, that'd be helpful.
And the primary key in one table would equal the foreign key on the other table.
Yes.
That's basically like the difference between
Yeah.
And then the different types of joins is just the different data that you get from those two tables.
okay, so like the same observations.
Yes.
Based off of the primary key.
Yeah, basically. And then like inner joins are just like things common between both tables. And then right join or left joins are literally the same thing. Just depends which table you put first. And I'm going to show you in like 2 seconds. I'm trying to like visually so you understand like what's going on.
Sounds like our top poly schedule, let's say like you have your social security number as one of the primary keys in the work schedule, you have your social security there too. Social security as the primary form.
Did you join them all?
Yeah, it is. Yeah.
Yeah, they're full outers, everything, just toss into one. So for the data we have here, one thing we can do is we can join the employees in like the titles table. So I just don't feel like typing things out. So basically, we're going to select the first name of the employee and the title from titles. And then So you're gonna say from the first table, which it doesn't matter which one you do first in this case. It does matter with if you're joining multiple tables on top of each other, because it depends if you're doing like left joins, right joins, like whatever. And it's based on like that first table, because if you continue piling everything up, it just like narrows down how much data you have basically kind of cascades. So it does matter most of the time, but this case doesn't matter. So you're just taking it from employees, and then I like to name it E because you don't want to type the employees out every time. So that's what the E is. And then we're going to left join titles, and then we're naming that T. And then you have to say what you're doing it on. So basically the overlapping, sometimes it's not named the same, to be honest. So you kind of have to like look up the data, but in this case it is, where employee number is both in the employees table and the titles table. So we can join these together. And so that's how you're joining them. You say on this primary key equal to this foreign key. Does this make sense?
Yeah.
I think I have.
So left join is like, you only care about the data on the website. Or.
And
You
then, yeah,
only care about the data you're from.
Yeah, and you get all of those.
If you have data,
All of
that
those
doesn't
from
match,
last time.
right? So like, you have like A and B, right? So if there's data that in A that's not in B.
Because there's a way you can bring it up from
You
workbench.
get it.
oh, there is.
Yeah.
Actually,
So what happens?
I haven't
oh,
used
really
it
quick,
much.
can you see how they have like the first name and then all the titles? Yeah, so that's basically because we were able to do that because we joined the tables together. Because first name's only in employees and titles only in titles. So by combining the tables, we can get more data.
You go to database. Is that reverse here?
For
So
full outer
cool.
joins and SQL support.
Connection.
No, I think it's say.
Really? What's a random?
No, sorry. it
Whatever you're
is
talking
a- You know what a natural is?
Yeah.
So I think a joint is a natural. I'm not too sure. I'm pretty sure it's an algorithm.
You know what this? is? Just like.
Yeah.
Is
So then
is the regular.
get
join
Okay.
and SQL.
That around.
So this is just like an ER diagram. And basically when you look, why can't I zoom in? Okay, let's big enough. So when you look at it, these are like little keys, they're kind of blurry, but that means that this is the primary key, which we see here. Yeah, so this does not have a primary key, which
What is it?
wait, it's the red.
The primary, I guess, yeah, it's just a foreign key.
So the red are foreign keys.
So those employee number and department number together are the primary key essentially. So that one,
I want to explain this.
I'm a bit from all this stuff. So it works.
Okay, so basically, this means that, yeah, this is going back a few quarters. Okay, basically, this means that it like connects to this. So this is like the primary, and this little symbol means that the foreign key is in here, which we can see is the employee number, which is also there. Same thing with this. So we can see how there's a department number here, which is the foreign key, and which is the primary key here, and so you connect them via that. This basically helps you outline and see like what tables you can connect, because sometimes we might want data from like this and like this, but the problem is you can't, like there's no connection straight to here, so you have to go through this table and then this table, or that table and that table, in order to get the data from that table and that table together.
Okay.
Which is why the joining is so important. So you have to be like, okay, like department and like left join, department employee. Actually, that's a lot. You cannot do that. Sorry. So we have to be like departments, like left join department manager on the department number. And then for this, you have to be like left join titles on the on employee number. And then basically that's how you join all the tables together, and then you'll be able to grab data from all three of those tables. That makes sense?
Yeah, you have to get something common.
Yeah.
So for the tables with foreign keys, is that just like the word for like the table that you're bringing into the left join, or is that like you have to specifically call it that when you create a table, like a foreign key, as opposed to?
So if you don't, it doesn't, best practice is to call it the same thing. Sometimes it's not called the same thing, but it won't be the same thing. Does it have to be called the same thing?
No, I don't think
I don't think so.
it
It doesn't. It does. I've done data where it is not called the same thing. When you look at it, it is the same numbers. Like they might call okay, just this is a dumb example, but like in one table, my first name might be called like first name. In another one, it might be called just like name.
Yeah.
And so like stuff like that, but like it's the same thing. So that's the problem, which is why you just really have to look at the data and like what number you're looking at. Yeah, any questions? I hope I explained that well. It's kind of like basically when you're joining the table, you know how in an Excel sheet you have like, okay, like all these things, for example. And then if we like left join like some other table, you're just adding like that information into that row.
Okay.
Yeah. So like if I want to like add like my person table, like hair color, and then there was like a hair color table that had like the same social security number or something. Let's just pretend like this doesn't make sense how much, but then we would add based on the social security number, like the hair color to that row, because we know that it's associated with that person because of the social security number. Does that make sense?
Yeah. So like when you're creating the table, like we did the first step, we did like social security, integer, not null, primary key. And then if you wanted to use a separate table to left join the original one, would you then do for this, the social security, which you're joining based off of, would you then do social security integer not null foreign key? Or
There's a foreign key.
There is a foreign
or
key,
is
but you
foreign key
don't
just the word for the one that's like the?
you don't have to label it foreign key though.
Okay.
I don't know, because like I was going through my notes.
Do
Adrian,
you?
So,
Yeah,
so
but
if you want to, you don't necessarily have to join on keys, but if you want to, like, call it foreign key, there is a way to do that.
Yeah, and you don't have to, because like think about it realistically, like you're not really gonna know exactly what data you always need, so it doesn't make sense to like say, oh, foreign key like all the time, because otherwise everything would be a foreign key. So you can join on anything though, as long as there's like a connection between them.
Totally cool. Unfortunately, we weren't able to get more detail on join. But it's pretty deep stuff. Yeah, hopefully we get something out of it.
Definitely good introduction.
Yeah, because a lot of it's kind of like, I don't know if you use Tidyverse and R, where you kind of like